Hey guys, this is our second video from the series of investments and interests. The question that we want to find out the answer to today is, what happens if you take a monthly invest of $1? That is not an initial investment, that is every month you put aside $1. And the capitalization of your interest that's R is done monthly, and you make this $1 investment recurrently over every month for n months. What is the amount of money that your investment fund will have at the end? This is the question that we want to answer today. Now, before we go into the solution, I just want to remind you to like, subscribe, and don't forget to check our 7 Minutes Math community. It's right in the description below. It's 7minutesmath.com. You have there access to our math community, our question, answers, problem, a great community that can support your question, your answers, and also you have access to our newsletter and many other interesting and very useful products. Now, as we want to continue our problem, let's say we make the investments over n month, $1 every month, and see what actually happens with every little investment over the time. I'm going to draw a table here and explain it. So here's how we're going to work with this table. We have month number 0. That is the moment when we make our initial investment. That is $1. And as time goes by into this direction, what will happen after 1 month, so in month number 1 of investment, with our $1 investment? And according to our previous video, if you haven't seen it, make sure you watch it. We have a 1 plus R amount of money. Then you have the next month here, you have 1 plus R to the power of 2. But also in the first month, when this initial $1 has just increased to 1 plus R, you make another deposit. So you have 1 over here. In the second month, this will be 1 plus R. And also, you have your investment that corresponds to the second month of investment. As we go to month number 3, again, you deposit your monthly $1. The amount of money of $1 from the previous month, month number 2, it's 1 plus R, because only 1 month has passed for this investment here. For the month number 1, it's 1 plus R to the power of 2, and here it's 1 plus R to the power of 3. Now, as time goes by, just for our initial investment, it will be obviously 1 plus R to the power of n. Here you have 1 plus R to the power of n minus 1. Here you have 1 plus R to the power of n minus 2, and here all the dots, 1 plus R to the power of n minus 3. Now, when you make your final investment here, let's assume you also have this one. It's 1. You want to add up and see what is our final amount of money. Well, it's everything that is right in this column over here, because every column here is describing what has happened because of these rules that we have set to all our monthly investments. This is the way they progress towards the end of our investment. So if we sum up all this column over here, we will have S of n equal 1 plus R to the power of 1 plus 1 plus R to the power of n minus 1 plus 1 plus R to the power of n. And this is a very simple geometrical progression with ratio 1 plus R and initial term 1. And this sums up to 1 plus R to the power of n plus 1 minus 1, 1 plus R minus 1, this is the ratio minus 1, and we're going to simplify this a little bit. It's 1 plus R to the power of n plus 1 minus 1, all divided by R. And this is our formula that will yield the amount of money that you will have at the end of your investment if you invest $1 monthly with an R interest, and the investment is done over R months. Don't forget to like, subscribe, and also register in our 7 Minutes Math community for the newsletter. See you next time.